Which of the following would react slower than benzene in an electrophilic aromatic substitution reaction? So what we have drawn up here is the generic mechanism for an EAS, or electrophilic aromatic substitution reaction. So we can see what we want to look at is what role is the benzene ring playing. So then we can decide, well, how does changing a substituent on the ring cause it to react faster or slower? So we can see in this first step that the benzene is acting as a nucleophile in this reaction. And so this means we want to consider what's attached to the ring in terms of whether or not it can donate electrons, which would make the ring more nucleophilic, or if it withdraws electrons, which would make it less nucleophilic and slower. So for something to react slower than benzene, it's going to be less nucleophilic, which means that it's less nucleophilic because the electrons are being withdrawn. So we're looking for an electron withdrawing substituent. So we can have something that is electron withdrawing through induction. So if you have an electronegative atom like a halogen, oxygen and nitrogen, we'll see, although they are electron withdrawing through induction, they can also donate through resonance. And so also we want to look for resonance in terms of electron withdrawal. So if we look at A, we see we have this carbonyl, and with the carbonyl you can pull electrons out by resonance. So that's electron withdrawing. So because that's electron withdrawing, this ring is less electron rich, it's less nucleophilic, and so this will react slower. So we actually found the right answer. Let's go ahead and check the other ones. So if we look at B, we have lone pairs of electrons on oxygen. And so we might be tempted to say that oxygen's electronegative, so it's going to withdraw by induction. Yes, but it's also in the second row of the periodic table, the same as carbon, so you can have this really good overlap of your p orbitals. And so this actually ends up activating the ring. It's electron donating. So this would react faster than benzene, right? And A here, we already circled as the right answer, will react slower. If we look at C, we've got an alkyl group. Alkyl groups are electron donating by induction. It's not as powerful as of an effect as resonance, but nonetheless, this will still react faster than just an unsubstituted benzene. And if we look at D, we've also got a carbonyl, so this one could be a little bit tricky. You might think it's going to do the same thing, but this carbonyl is not what's directly attached to the ring. The oxygen is, and the oxygen has lone pairs of electrons, just like in this phenol. So it can donate electrons into the ring. It's not going to donate as much because these electrons are also tied up in resonance with the carbonyl, but it is still going to donate into the ring, making this react faster than an unsubstituted benzene. So when we're deciding if something reacts faster or slower, we're looking to see if we have an electron donating group, which makes it go faster, or an electron withdrawing group, which is going to slow the reaction down.